video, we're going to find the modulus of a complex number. So what is a modulus and why do we want to find it? So the modulus of a complex number is the distance from the point of the complex plane to the origin. So that's 0, 0. So to calculate the modulus of a complex number, it's just like finding the distance formula. So if you remember the distance formula, the distance equals the square root of x2 minus x1, where x2 is the most right point and x1 is the most left point, squared, plus y2 minus y1 squared. And the squared would ensure that both of these are positive. Alright, so let's talk about this. Let's grab our graph and let's talk about the value 5 minus 8i. So each block represents 1 unit. We're going to go 1, 2, 3, 4, 5, and then go down 8. 1, 2, 3, 4, 5, 6, 7, 8. Because what we're looking at here is 5 on the real, negative 8 on the imaginary. Alright, so now I want to figure out the distance from my origin, or the modulus, the distance from my origin to that point. So this distance right there. Alright, so what we're looking at here is the distance equaling, I'm going to do my real part, so 5 minus 0, because we're going from the origin, squared, plus negative 8 plus 0 squared. Alright, 5 minus 0 is 5. 5 squared is going to be 25. Negative 8 plus 0 is negative 8 squared is going to be positive 64, because negative times a negative is a positive. And we get the square root of 89. We could probably simplify that a little bit more. But this is what we're going to look at for that modulus. All right. And you know, we don't necessarily have to use this distance formula. If you wanted to take another route for this, and it's always good to see different routes, we could also get the same results using the complex number and its complex conjugate. So we have 5 minus 8i. Remember the complex conjugate. This is the distance, the absolute value for the distance. The conjugate is going to be the opposite sign in the middle. So this is a plus. This is a minus, so we're going to use a plus. Foil that out. We get 25 minus 64i squared. I squared is going to be negative 1, so negative 1 times negative 64 is going to be positive 64. And we get the square root of 89. So in general, the modulus of a complex number. So in general, the modulus of a complex number z equals a plus bi is the bar equals the square root of z times the conjugate. So this right here, this symbol right here is our conjugate. So conjugate. That's not the color I was using. That's the color I was using. Or in other words, a plus bi times a minus bi, or the square root of a squared plus b squared. All right, so that's basically our modulus. This is used to find the distance from the origin. And just a quick study tip, just as the absolute value of the real numbers gives its distance from 0 on the number line, the modulus of a complex number gives the distance from its corresponding points to the origin on the complex plane. Alright guys, so this is the end of the modulus. If you guys have any questions, always feel free to ask, and I'll catch you in the next video.